morning, everybody, and a special welcome to our primary audience, the Tshwane University of Technology. My name is Aisha, and my co-host today is Prudence. Prudence, give a wave. And she will be handling the Q&A part of today's talk, which forms part of the Share Screen Africa African Geology series, Geology and Soils series. So in our previous talk, we spoke about looking through the telescope and how some of the planets got their name, including our terrestrial planet, planet Earth. In today's talk, let's look at what Earth looks like through the microscope. It's rather poetic, actually, and so much that it brings about the famous philosophical quote by William Blake. To see the world in a grain of sand and heaven in a wild flower, you hold infinity in the palm of your hand and eternity in an hour. But is sand and soil the same? Our speaker today will discuss the chemical characteristics of soil. Michelle Awuor is passionate about finding solutions to the challenges facing farmers and their communities. She's committed to supporting the implementation of sustainable agricultural practices that will improve livelihoods and build a better future. With a background in integrated soil fertility management, she specializes in developing resilient farming systems that will build soil health and increase soil fertility while being sustainable over time. She currently works for Grounded as a regenerative agricultural specialist, and this talk will explore the chemical characteristic aspects of soil from soil regeneration perspective in. We will discover how soil contributes to the world around us and gain a deeper understanding of the hidden wonders beneath our feet and how we can repair them. So with that, I hand over to you, Michelle.
Thank you, Aisha, for the introduction, and good morning, everyone. So for our webinar today, we'll be looking at the part 2 series of the webinar, and that is soil chemistry. To start us off, I will introduce who we are and what we do as a company. So at Grounded, we are on a mission to scale regenerative agriculture in Africa, agriculture that can combat the effects of climate change, agriculture that can enhance the life that is in the soil and restore its fertility, agriculture that can increase the biodiversity below and above the ground, and one that can hold water for plants to survive between the rainy seasons. What we do, we take a value chain approach to drive the transition to regenerative agriculture, reducing barriers and also ensuring that economic incentives create positive change. So for farmers and harvesters, we provide regenerative agriculture support and offer premium prices for the products. Then through our local operating companies, we provide a market for the products, which are then processed and sold to traders who turn them into the final products and brands we see on our shelves. We have a diverse team that operate from different areas. We have teams in Netherlands, South Africa, Kenya, Tanzania, and Zambia. So where we are now as a company, we have 3 operating companies. We have the Langkloof Honeybush Company in South Africa. We have Simalaha IFC in Zambia, and Trianon Spices in Tanzania. So for one of our operating companies, Trianon Spices, we work with smallholder farmers who produce spices, and that is black pepper, cinnamon, cardamom, and cloves. And we also have our own nucleus farm that serves as a model farm. So how we engage with farmers, we work with farmers in groups led by the lead farmers. And the lead farmers are assigned a model farm that are set in different villages. So this model farm serves as training centers where farmers come and learn. And once the produce is ready, they are sent to the factory for processing. For our webinar today, we will be looking at what plants eat, what are the available nutrients, and how we can increase nutrient availability from a practical perspective. So what do plants eat? Essentially, plants make their own food. They eat glucose, a product of photosynthesis. So glucose is the primary source of plant nutrition and essentially is the main requirement for their growth. So in the same way that eating sugar provides us with energy to work and go about our daily activities, sugar provides plants with the ability to grow and the energy to perform other critical functions as well. So when they make their own food, some of the ingredients they require are nutrients that they extract from the soil. Other nutrients they require, of course, are water, light, and carbon dioxide. It is usually so common to think that fertilizers are food for plants, but in reality, they are not. The fertilizer's only job is to supply nourishment to plants and to enhance their growth and development. So fertilizers work on plants the same way vitamins and supplements help nourish our bodies. So how do plants eat? Plants eat via roots. So the root is usually surrounded by soil, which have pores, allowing air, and is also surrounded by water. So because plants need nutrients to make their own food, nutrients in the soil will first need to reach the roots. And this usually happens via different mechanisms. And one of the mechanisms is by root extension, which is very important to find new nutrient sources. So the root hair will absorb nutrients from the soil solution and also from the exchangeable ions on the soil particle. So also again, depending on the properties of the soil, at times it's very difficult for the root hairs to absorb nutrients, more so if they are strongly held by the soil particle. And to overcome this, the root hair is usually lined up by energy carrying molecules, which then pumps nutrients from the soil solution and make it possible for the roots to absorb nutrient from the soil. And this mechanism of nutrient absorption is usually called the proton pump. So for plants to absorb nutrients via roots, they need to form a symbiotic relationship with microorganisms, specifically the beneficial bacteria and fungi. And this relationship is mostly initiated when nutrient depletion occurs, and that is when there is low nutrient concentration in the soil or when the nutrients are deficient in the soil. So in this situation, the plants will rely on fungi to facilitate the uptake or the absorption of nutrients. So what the fungi does at that moment is to form a symbiotic association with the plant roots, in which the fungi will be integrated into the physical structure of the roots, as we can see on the second image, where the mycorrhizal fungi has infected the root tips. Once this infection has been initiated, the fungi will produce an enzyme which will convert the non-soluble forms of nutrients to soluble forms that can be taken up by the plants. So through this association, plants will obtain nutrients from the soil and the fungi will obtain sugars from the plant roots for their nutrition. So the same applies to the soil bacteria, Rhizobium, which symbiotically interacts with roots of now a leguminous plant to form specialized structures called nodules, in which nitrogen fixation takes place. And we can see that in the first image where nodules has formed in plant roots. So what are the available nutrients? One of the functions of the soil is to supply nutrients to plants. And soil chemical properties such as soil pH and soil CEC are mostly involved in the availability of these nutrients. So looking at the soil CEC, or the soil exchange capacity, it is a characteristic of the soil that influences the soil's ability to hold on to nutrients. So in most cases, it's usually influenced by the amount of clay and organic matter content of the soil particle. And the CEC usually have a lot of negative charges. And these charges dictate the interaction of ions in a soil solution. So in the soil solution, you'll find both negative and positive ions. And the soil particle, as you can see, it's lined by negative charges. So it will only attract the positive ions, and that is the law of attraction. So the total number of cations, or the total number of positively charged ions a soil can hold or attract, is the soil cation exchange capacity. So the higher the negative charge, the more positive ions, or the more nutrients with positive charge that can be held by the soil. So based on this alone, the CEC is in most cases referred to as a storehouse of nutrients, and it's more like a bank account where plants withdraw their nutrients from. And in most cases, it's usually used to define how fertile the soils are. It has a huge impact when it comes to fertilization practices. You find that high CEC soils have a huge reserve capacity to hold on to nutrients, thereby reducing the intensity of nutrient losses, especially through leaching. And in such soils, you can apply large amounts of fertilizers in one application without worrying about any huge losses. While in low CEC soils with less charge and less capacity to hold on to nutrients, you find that less nutrients can be held and that they are prone to losses via leaching. And again, in such soils, it is usually recommended when you're applying your fertilizers, then you spread the application of fertilizers in smaller amounts as opposed to one big application. So nutrient availability will also depend on the type and the composition of the parent material that form the soils. The parent material is what determines the original supply of nutrients that are released during the process of soil formation. So the nutrients present in the soil naturally are as a result of the rocks that formed the soils in the first place. So during the weathering process or breaking down of these soil minerals, microorganisms are definitely involved, and they produce organic acids that enhance the release of nutrients from the parent material. So for like soils in Kenya, especially from coastal Kenya, it's said to naturally contain adequate amount of potassium. And this is probably because of the nature of the rocks that form this soil. So maybe the mica that is heavily distributed in the region. Another source of nutrients is the organic matter, which upon decomposition releases plant nutrients. So organic matter, it's a fraction of the soil that is made up of decomposing materials, so either plant or animal material, and also has a lot of microorganisms in it. And some of the organic materials that increase organic matter in the soil include animal manure, crop residues, and also composts. Okay, so as an example of organic matter as a source of nutrients, we look at Simalaha IFC as a case study. At the farm, we managed to increase the organic matter levels in the soils by up to 2%. When we started the farm, the soils had an average of 1.3% of organic matter. And over 2 years, with the incorporation of different organic materials and different practices, the organic matter levels rose to over 3.5%. And with this increase, we noted that whenever there was an increase in organic matter, there was also an increase in nutrients in the soils. And some of these nutrients were nitrogen, phosphorus, and sulfur. And these nutrients would increase as the organic matter in the soils increased. Okay, so how then can we increase the available nutrients? So since the soil CEC and pH dictate the availability of nutrients, increasing the available nutrients will then require us to increase organic matter content of the soils that dictates the soil CEC and also having an ideal soil pH. One way of increasing the available nutrients is to, of course, have the ideal soil pH. So this is basically the acidity or the alkalinity of the soils. You find that when soils are acidic, most of the major plant nutrients like nitrogen, phosphorus, and potassium will be locked up in the soil, making them deficient or unavailable. On the other hand, when soils are alkaline, then the minor nutrients will be deficient in these soils. So to increase the availability of all the nutrients, then you have to correct the pH of the soil such that it's not acidic or alkaline. Generally, the ideal soil pH is close to neutral, and it's at this pH range that nutrients become available, and it's also at this pH range that is acceptable for most plant nutrients. So other than plant nutrient availability, soil pH also affects the activity of soil microorganisms. You find that the population of microorganisms like bacteria that decompose organic matter declines, and their activity in nutrient cycling is hindered in acidic soils. So if their population declines, then it reduces also their availability to mine the nutrients and to make them available. One way of correcting soil acidity is to use lime. And lime is a soil amendment input that is made from limestone rock. And the rock naturally contains calcium carbonate, which is effective in neutralizing the acidity of the soils. So to showcase the impact of soil pH on nutrient availability in crop production, trials were done both on pots and replicated on the fields. And all the plots were the plots and the fields were planted on the same day. So from the pot trials, you can see maize planted on an acidic soil, the control bucket having stunted growth, and it's really struggling. When lime was added to the same soil on the bucket, the crop is thriving and looking healthy. So the same was evident when the maize was planted under similar conditions on the farm. You find that the production on acidic soils was very poor, and it only yielded 1 ton per hectare, when compared to the farm that incorporated the use of lime. So what lime does is to neutralize the acidity of the soil, which then unlocks the locked up nutrients in the soil, making them available for plants to utilize and use. Okay, so increasing available nutrients will also require us to increase soil organic matter. And one way of increasing the organic matter levels in the soil is to use organic materials such as composts and manures. Compost distributes a good amount of nutrients that are easily absorbed by the plants, and they also have excellent diversity of soil microorganisms that are usually needed to decompose these materials further, making the plants nutrients to be available. Another way to increase the available nutrients is to enrich the soil with active carbon. And you can increase soil carbon through the incorporation of high biomass producing crops such as cover crops, and also mulching with plant residues. Plant residues, being plant materials, contain carbon, which ultimately, upon decomposition, goes through the carbon cycle. And with the carbon cycle, the cycle can help maintain or increase organic matter levels in the soil over time. Plant residues are also a good source of food to microbes. And if microbes are well fed, then they are provided with more energy to recycle, more nutrients, making more nutrients available to plants. So increasing nutrient availability is also a combination of knowing exactly what nutrients are needed by plants for healthy growth. And one of the first steps to take is to soil test, to identify and correct any nutrients that are deficient in the soils. So once the limiting factors are identified, then the right input applied to the soils, you find that the plant growth is encouraged, and the plants produce high biomass that can then be returned to the soil as plant residues. And when the residues are returned into the soil, then the cycle continues. The residue promotes increased carbon in the soil, and also feed the microorganisms in the soil that again help in nutrient cycling and increasing nutrient availability. Organic fertilizers are also good sources of nutrients. And these are products that are naturally mined or produced, and are used to deliver additional nutrition to plants. So increasing nutrient availability will also require us to have a good balance when it comes to fertilization. And this calls for a guided fertilization plan. Fertilizers are essentially salts, and living organisms are intolerant to excessive salinity. So when you expose them to high saline condition, by default you reduce their population, and again you reduce their ability to mine the nutrients. And also, using excess fertilizers doesn't necessarily equate to higher yields. If anything, it only increases our production costs in most cases. So if using fertilizers or applying organic inputs to increase the available nutrients, then we want to maximize the results of our investment and achieve the highest possible yields. As when we are supplying nutrients to the plants, the ultimate goal is to achieve the highest yields as possible. So to look at this, we look at the law of minimum as a guide to nutrient management to avoid over-fertilization and also overnutrition. And the law states that the yield achievable is dictated by the nutrient that is most limiting and not necessarily the nutrient that is available in plenty. So one way to visualize this concept is to illustrate it with a dam. And we have an image of the dam on your right-hand side. And the water being held back by the dam represents the yield potential. Then there are holes that are coming. There are holes that are coming out, from the wall. So the holes in the dam represent the yield limiting factors that ideally would allow the yield potential to be decreased as the water leaks out of the holes. So the goal is to identify which holes are leaking and plug them to maintain as much yield potential as possible so that we don't lose the yield, coming out from the dam. So in this illustration, instead of using inputs to increase nitrogen in the soil that is already in sufficient amount, because if you look at the nitrogen hole, it doesn't leak. So meaning the nitrogen in that particular soil is in sufficient amounts. So we don't necessarily need to increase more nitrogen in these soils, but instead using inputs that are rich in potassium and phosphorus, which are leaking, will make more economic sense as it will move, the yields from your current yields to a more targeted yield potential. Okay. So in summary, we've looked at what plants eat, and that is glucose, and that they require nutrients for their nourishment and development, which they take up via roots. We've also looked at the available nutrients, which is dictated by the soil chemical properties. And we've also looked at how to increase the available nutrients by increasing organic matter levels in the soil and also increasing the microorganism population in the soil. And also having an ideal pH by managing our soil acidity and alkalinity. That is all I had for today, and thank you for your time.
Hi, Michelle, and good morning, everyone. Thank you for your very insightful talk. I think everybody was, knowledgeable. They got some knowledge from all the things you say today. So thank you for your time and thank you for your very interesting presentation. I am going to open the floor now for the Q&A. If you'd like to ask a question, you can lift up your virtual hand. Otherwise, you can write the message on the chat. I know that we have one question from Asima. Asima, I don't know if you'd like to unmute and say your question, or would you prefer that I read it out for you? Okay, I'll read it out. Asima's question says, you also say that the fertilizers act as nutrients to the plants, but they also cause acidification and soil crush. So would you recommend fertilizers to be used by the agricultural industry?
Fertilizers provide nourishment for plants to grow and develop. So use of fertilizers should be, I think fertilizers need to be used, but at the right time, at the right place, and applied at the right quantities. And that needs to be guided. So ideally, you need to identify the deficiencies that exist in your soils and help address the deficiencies by using the right fertilizers in the right quantities and amount. Yeah.
Okay. We have a second question. She also says, fertilizers make the crops grow much more faster and also bigger. So would you really say they actually give nutrients? Let's take, for example, oranges. If they are in the older days, they were small yet juicy, and nutrient, but now they are bigger and dry. So would you actually say the fertilizers with the agricultural industry use give nutrients to the plants?
Yes, fertilizers are a source of nutrients, and that's why we use different fertilizers to address different agronomy challenges at the farm. So I'll give an example. We use a DAP at planting because we want the fertilizer to supply phosphorus that is essential in root development. So yes, fertilizers are a good source of plant nutrients.
Okay, Asima has another question, but I have a question. I'd like to know, since I think we are getting into regenerative agriculture and using alternatives and supposedly more natural alternatives, what you spoke about pH and the importance of soil pH. I'd like to know, for the everyday farmer who doesn't have access, I don't know how you measure the pH of the soil, but is there alternatives? Like, is there a plant that you can put, and based on how it acts or how it looks, you know what the pH looks good for you to plant certain things? How do you navigate the concept of pH and soil for a person who doesn't have access to the technology to measure the soil pH?
So the soil pH is not visible at the farm. You can't just look at the soils and say that it's of a certain soil pH. And that's why you need to, test the soil. Either you take the soil to the lab to test it, and there are also mobile soil pH meters that one can actually use in the farm. Then, of course, there are indicator plants that when you see in your field, then you know your soil pH status in the soils. Yeah.
Okay, cool. That's very interesting. The next question from Asima is, how do you deal with water issues? As we know, the agricultural industry consumes a lot of water and affects the water quality. And we know that we have limited amount of fresh water that's available, and the rest is salty. I'm not sure if you mentioned this, but how do you deal with soil erosion and degradation caused by the activities of farming?
Okay, so water preservation now calls for conservation farming, and that's where we talk about regenerative agriculture. So implementing practices that would actually restore water, and practices that would ensure that the soil is covered throughout so that it's not exposed to elements of erosion. So if you plant cover crops, then it ensures that your crop is covered all through the season, and that alone reduces, the incidences of erosion, either through runoff or wind erosion. So also when you implement practices as mulching, then it also ensures that the soil is covered the season. So the idea is to always cover the soils and protect the soils at all costs to limit to avoid the incidences of soil loss. Yeah.
Okay. Zabang says, don't most of the nutrients in conventional fertilizers lock up in the soil?
Okay, so nutrient lockup is usually as a result of soil pH, and with soil pH alone, we can be able to unlock, the locked up nutrients in the soil. So what happens is when the soil is so acidic, it's so acidic that I usually like to give an example of, the effect of acid on our skin. On our skin, if it gets to our skin, then it burns it. So the same principle applies to, the nutrients that are in the soil. So if the soil is so acidic, then you find that it will lock up the nutrients and make them unavailable. So when we slowly neutralize the acidity of these soils, the nutrients are released from these soils and made available. Yeah.
Ooh. Can you tell us about some of the indicator plants? Like how would you know? Do you know from when you plant it? Do you know from what it looks like as it's growing? What is an indicator plant, and what does it look like?
So most of these indicator plants will be weeds, and I might not know the scientific name, out of at the top of my mind, but most of these indicator plants will always be weeds. Yeah.
Do you work with like community farmers? Do you work with communal farmers? Or you work with large scale big farming industries?
We work with both, but mostly we work with smallholder farmers who, again, practice, I would say, regenerative agriculture by default, because they apply some of these principles by default. So what we are doing is just to guide them on what they need to do at certain stages of production.
So have you found that from your experience, the smallholder farmers naturally kind of know how to work around the soil pH, even if they don't know what it's called in English? Have you found that there's that inherent indigenous knowledge on like things like that, like technical things like that?
Yeah, I would say yes. And most smallholder farmers rely on traditional knowledge because for like our grandfathers used to apply ash to their farms. And if you ask them why they were applying ash, then they'll tell you it's a source of nutrition. And actually, ash has a liming effect, and it's also a good source of potassium. So
Okay.
it is something that they are doing, but they might not necessarily know why they are doing them. But it's something that they are doing, and it's guiding them in the production. Yeah.
Cool. Thank you, Michelle. Aisha, we can take your question.
Okay, I'll unmute myself. I'm trailing on Tsepang's question about nutrients, but there's no nutrients being locked up in the soil. I just want to know, or can you elaborate on whether we can manage soils to mitigate climate change by reducing like greenhouse gases?
Yes. Now, when you talk about greenhouse gases, we talk about carbon dioxide and nitrous oxide that is actually mostly produced from conventional fertilizers. And that's why when you talk about conservation agriculture, then we promote the use of organic fertilizers more than the synthetic fertilizers so that we reduce the level of the nitrous oxide that is coming out from the synthetic fertilizers.
All
Yeah.
right. Thank you.
Cool. CL, we can take your question.
Hi, Michelle. Thank you very much for that talk. First of all, that was really, really enlightening. You mentioned soil mycorrhiza or mycorrhizal fungi, and I'm just wondering whether is that something that you would be able to add to the soil or encourage the soil if you wanted to start farming some land that had been degraded? Because I know it's very important to soil health. Can you buy a mix that comes with mycorrhizal fungi in it or something like that?
Okay, so you can actually add the population of microorganisms in the soil by using the organic materials such as composts. And you can also use biostimulants. So these are, they are soil amendment products that are rich in microorganisms. And, I think, I know you've heard of trichoderma, then there is one that it doesn't come on my mind now, but there are biostimulants that one can actually use to encourage the population of the microorganisms in the soil.
Okay, fantastic. Thank you. And have you done any trials in the work that you've done before with soils that have more mycorrhizal fungi and not, and compared the difference in the growths?
I wouldn't say personally, I've not done any trials in that regard, but Daniel is more knowledgeable in that area of soil biology, so he's better suited to give insights on that. Yep.
Okay, great. Thank you. Maybe we can speak a bit more about this with you and Daniel in your next talk when you do it together.
Sure.
Okay,
Hi,
great. Thank you.
sorry, CL. Hi, Johan. We can take your question.
Prudence, well, I would like to see Daniel's videos on, so if Daniel wants to quickly come in and elaborate on that, you're welcome. Thanks, Daniel, for being here. Appreciate it.
Hi guys, and thanks Michelle for an awesome talk. Yes, you can buy mycorrhizal inoculums specifically. There's various brands out there. Some of them use imported mycorrhiza. So that's, let's say it's a mycorrhiza that's been grown out from isolated from American soils, and they don't work so well. So try and find a brand that uses indigenous mycorrhiza to your area especially. And we have done some trials on that, and we are currently doing one large trial with a rooibos farmer on the use of mycorrhiza and looking at how that improves. It especially improves the phosphorus availability and uptake of your plants. So that's, like Michelle had said, phosphorus is one of the key nutrients that mycorrhiza assists in taking up.
Fantastic. Thank you so much for coming in on that, Daniel.
Okay, Prudence, may I ask my question?
Yes.
Okay, good. So Michelle, thank you very much for a super talk. I would like to ask if you can maybe say more about the fermentation process of organic material as a way to create fertilizer, especially for perhaps to farmers that don't have access to commercial fertilizers or even organic fertilizers. Thank you very much.
Okay, so I can talk briefly on this, but then again, Daniel has more experience on this. So fermented organic inputs are actually good fertilizer alternatives for the organic farmers, because something like liquid fish, it's very high in nitrogen, which is usually a very limiting nutrient when it comes to organic material. So while compost will give you 0.18% of nitrogen, liquid fish would give you about 5% of nitrogen that is readily available for the plants. So when it comes to the process, then again, I would like Daniel to jump onto this, because he actually has a lot of experience using liquid fish as a fermented liquid fertilizer.
Thanks, Michelle. Yes, so I think you did share one image of how bacteria break down parent rock material into soil essentially, and fermentation is that process. So fermentation is performed by bacteria that produce organic acids naturally. So it's a little bit different to the acidification of the soil that Michelle was talking about. These organic acids don't really affect the soil pH as much, but the organic acids react with nutrients in the soil and make them more available as well. So it's a way to use microorganisms to effectively increase the availability of certain nutrients, and then to also break down organic matter much quicker. Fermentation typically creates available nutrients from organic matter within 6 weeks, where composting would take 3 to 9 months to perform. So it's a quicker way as well of releasing nutrients. And it's a certain class of bacteria and fungi that you use, and they are acidifying microorganisms. So they produce these organic acids like lactobacillus, which is bacteria that creates lactic acid as a byproduct in its metabolism. And that lactic acid can then react with nutrients and make them more soluble. If that answers the question.
Thanks, Daniel.
Thank you very
We have another question from Silo. He says, first, he gives a compliment, says, thank you, Michelle, for the wonderful talk. If you can be able to give more details on indigenous ways of taking care of the soil, even the kinds of indicator plants included, our crops, for example. You mentioned one method of using ash. Do you have more ways that can help us as small-scale farmers that are easily accessible?
Yes, so farmers can use animal manures as a source of nutrient, and Yeah, mostly animal manures, and also, farmers can actually graze, their livestock into the farms. So, for instance, in maize plantations, because most farmers at least plant maize. So of course you can't bring in your livestock in season when the crop is on the fields. But after harvesting, then farmers can graze their livestock after harvesting, so that they feed on the stock, and the manure droppings also would enrich the soils with nutrients. Yeah.
Okay, it's interesting. I just have a last personal question, I think. I'd like to know what your experience has been like for you as a young Black woman working with smallholder farmers. Have you found that they're more receptive to you, or have you found that they're a little bit challenging because you look relatively young?
Okay, so my approach to working with smallholder farmers is, from the point of learning, because I usually believe they've done farming many years than I have. And in most cases, when I'm working with smallholder farmers, I tend to, depend on what their experience has been, and what has been working for them in the past. So I'd say mine is just to support, provide guidance on what they need to do based on the current world happenings and the current technology that needs to be adopted. But if anything, it's a group of people that you actually gain a lot of learning and a lot of experience from.
Cool.
Yep.
Ofense, we can take your question.
Yeah. Good morning, everyone. It's not a question, but thank you for this presentation to Miss Michelle. And I've been asked for Ms. Dlamini asked me that I should say thank you for giving us your time to learn about soil. So as a class rep on behalf of the whole wildlife management class, I would like to say thank you on my behalf and on Ms. Dlamini's behalf.
Thank you, Ofense. I think we have no more questions, and we've come to the end of the Q&A. I will hand over to Aisha to do the closing if there's nothing else.
Okay, so because it's almost 25 past, and I think the next class, they need to prepare for the next class. Then I would also, just like Ofense, I'd like to say thank you on the behalf of SSA, Shares in Africa, to Michelle and Daniel. It was a very informative talk, and we're looking forward to the two of you speaking together on the 15th of September. Thank you to our audience, to our speaker, I think our co-speaker, and thank you, Prudence. And we'll see you guys on the 15th of September. And I think the rest of the class, I think we see you on the 8th. Our next talk is the 8th for this series. So thank you very much.